Hi everyone. Today me gonna share you something regarding problem solving in physics in year 2018 on February and March. The syllabus 9702. Uh, this the instruction first on the page one. Uh, we go to next page. This is the data from sum of constant number, speed of light every space is 3.0 times 10 to the power 8 minus meter second minus 1, and permeability and so on and so on. We don't need to discuss about this. Uh, this is also about some formula in physics, yeah. So uh, we don't have to memorize about the formula because formula is provided by Cambridge, yeah. This is about the uniformly accelerated motion, uh, motion straight line, work done, gravitational potential, hydrostatic pressure, pressure of an ideal gas, simple harmonic motion, velocity particle, and so on and so on, Doppler effect, and so on and so on. Okay, okay. We start from number one about the columns, which is the equivalent to the column. The column is unit of charge. Unit of charge, if you know the energy, sorry, the energy equals to QV. Then we know Q about the W over V. So the unit Q is coulomb, and unit W is joule, and unit V is volt. So we can decide this column equals to joule over volt. So the answer is B. Then number two, which throws the quantity in correct unit. Yeah, this is quantity efficiency, no unit. Yes, I think it's correct. Moment of force, Newton meters minus 1. I think this is wrong. Momentum, Newton seconds, is correct. Work done is joule. Yes, this is the wrong one, is B. Yeah. Why? Because moment of force, yeah. If we know about torque is force time D. So force is in Newton and D in meter. So the quantity of torque equals to Newton meter, not as Newton meter minus 1. Okay, number 3, two force equal magnitude are represented to coplanar vector, one directed toward to east and other directed toward to north. Yeah. East to north. What is direction single force balance to these two force? Yeah. Uh, if this is north and this is east, yeah. And we get the resultant of this force. We come to northeast, yeah, toward northeast, and the answer uh, northeast, toward northeast here. Continue to number 4. The density of vapor is 8 kilogram meter minus 3. A typical sheet paper has weight 210 millimeter and length of 300 millimeter. The thickness of peg for 500 sheets of paper is 50 millimeter. Okay. we know but the formula of density equals to mass over volume. So we know the mass is density times volume. So we have the weight in 210 millimeter. This is also same thing with 0.21 in meter. Yeah, and also the length here is, this is something with 0.3 meter, because 1 meter equals to 1000 millimeter. So the volume is multiplying by 0.21 times with 0.3 and times with between we separate we divide it. This is about height equals to 50 millimeter over 500 sheet. So this is 0.1 millimeter. Yes, 0.1 millimeter. If we change into meter, this is 10 to the power of 4 meter. So the density equals to the mass equals to density times volume. So the density is 800 times 0.21 times 0.3 and time 10 to the power minus 4. Yeah. We get this is in kilogram. Yeah. If you want to, after we calculate this number and then we change into kilogram, we change into gram. Yeah, we can this multiplying with 10 to the power of 3. Yeah, in gram. So we can decide this is let's say this is 8 times 0.21 times 0.3 time 10 to the power minus 2 and time also 10 to the power of 3, but this is already on in gram. Sorry. Yeah, we calculate we change from kilogram into gram. Yeah, this is the conversion from kilogram to gram. So we get the number here is equal to 10. So the conclusion is 8 times 0.21 times 3. Yeah, this is around 0.2 times 8 equals to 1.6. 1.6 times 3 around 45 or around, this is around 50 grams. Yeah, so the answer is C. Okay, continue to next number. The next number, yeah, person calculate potential difference across a wire by using measurement shown, which measure quantity has the greatest contribution the percentage uncertainty in the calculate potential difference. So the question is, which measure quantity has the greatest contribution the percentage uncertainty in the calculated potential difference. Also this uncertainty not as current, yeah, also not as diameter of wire, because this is the value a little bit big. Yeah, then this is about percentage uncertainty come to the amount of quantity. That quantity is the small thing. Yeah. Yes, The measure quantity which the measure quantity has the greatest contribution is from here, yeah, resistivity of metal in wire, yeah, because this is about the small number. Okay, now number 6, yeah, cathode ray oscilloscope CRO is connected to alternating voltage. The following trace produced on screen. The oscilloscope time base setting 0.5, yeah, the oscilloscope time base setting 0.5 meter second centimeter minus 1, and Y plate sensitivity is 2 volt centimeter minus 1. Which statement with alternating voltage is correct? Okay, 1 centimeter equals to 0.5 millisecond, yeah. We know about the period. This is period, time when one wave. This is period, yeah. So on the period we have four cube. So if this is 1 centimeter and this is 1 centimeter, so the period, actually this is the period is 4 times 0.5 millisecond. So this is about 2.0 millisecond. This is the period. Sorry, we see the period is 1 millisecond. This is the wrong answer. So how about the frequency? The frequency is 1 over t, yeah, 1 over 2.0. This is in milliseconds, so we can multiply with 10 to the power of minus 3, yeah. So we get this is power of 3 over 2, yeah. This is around 0.5 times 3, yeah. This is about the kilo hertz, yeah. So frequency we get 0.5 kilohertz. Yes, the answer is correct is B. Okay, continue number 7. A stone of mass drop a tall building. The significant resistance the slashing free fall is G. When the stone is falling at the constant terminal velocity, which information is correct? Okay. Option A, magnitude of the acceleration of the stone, yeah, is G. Magnitude of the force of gravity on the stone is 0. Is it correct? Yeah. Magnitude of the force on the air resistance of the stone is mg. Or option B, C, and D. Okay. The magnitude of the acceleration of the stone, yeah. So we have D. Why? Why? This is stone is dropped from tall building, yeah. So this only gravitational acceleration. So magnitude of the force of gravity of the stone is 0. Why? Because, yeah, back to the concept of the Newton first law, yeah. If the on the constant terminal, yeah, of the constant terminal, yeah, of the constant terminal velocity, v is constant. So A equals to 0, so total force equal to 0. Yeah, total force equals to 0. This is about the what the force, yeah, acting on the object. This is about mg, and this is about force buoyance. Yeah, so force minus mg equals to 0. Yeah, total magnitude of gravity of the stone. And this is about the air system. Yeah. So the the magnitude of the acceleration is 0, and magnitude of force of gravity of the stone equals to 0, and then magnitude of the force on the air resistance of the stone equals to mg, because this is equals to mg. So the answer is C. Okay, continue number 8. Yeah, the velocity time graph for the object is shown. This is velocity and y is time. Yeah. Area 1, area 2. How can total displacement the object determine? Yeah. Displacement, it's about the length of the particle when the particle is moved. Yeah. So we consider about the vector position. So the displacement equals to area 1 minus area 2. Why? Because this is on the y direction. Yeah. The answer is A, area 1 minus area 2. Okay, number 9. A girl throws ball vertically upward. It takes them 3.2 seconds return to her hands. Yeah, assuming the area system is negligible, what the initial speed, yeah, with the ball is thrown. Okay, this is time until the back in the her hand. Yeah, so the time until the high position is 3.2 divided by 2, or this is 1.6 second. So what the initial speed, if you use the velocity until highest position, VVO minus GT. Yeah, this is to come to 0 on the highest position. VO minus G is, let's say this is 10, T is 1.6. So we get VO equals to around 16. Yeah, if the gravitational is 10. Yeah, so if the gravitational is below than 10, we said this is below of 16. Yes, I think this is around C. Yeah, 15 over 15.7. Continue number 10. Yeah, steel pellet each with mass 0.6 gram fall vertically onto a horizontal plate rate 100 pellet per minute. They strike plate with velocity 5 meter second minus 1 and rebound with the velocity of 4 meter second minus 1. What is average force exerted on the plate by the pellets? Okay, the pellet is mass 0.6 gram. Yeah, we can change this into 0.60 times minus 3 in kilogram, and then per minute is 6 second. Strike plate with velocity 5 and rebound velocity 4. Okay, we can use the formula of the impulse. Yeah, impulse equals to change of momentum. Impulse equals to F dt. Yeah, and this is equal to Vt minus Vo. Yeah, so F times delta T in 60 seconds, yeah, mass is 0.6 times minus 3, and Vt rebound velocity in 4 minus, this is minus 5. Why? Because the opposite direction, yeah. So we get this is around 5 minus this is 9, yeah, this is, I think this is around force equals to 0 10 to the power minus 1, this is 4, and this is by this one also, this is around 5, yeah, times 9, yeah, sorry, this is around minus 3 minus 4 minus 5, then around 9 times minus 5, and then if we see yes, still we want the horizontal plate. Oh, we have 100, so we can, if we on the 100, this is around every is around here, yeah, because time when 100, yeah, become okay. Number 11. The diagram shows force for forces as solar object, yeah. Which law describe the resultant force and resultant torque Q on the object? Resultant force, yeah, resultant force is if we see on the X and the Y 45 Newton, and this is also 45 Newton, become 0 on the Y direction, and here is 30 Newton, also 30 Newton, and this become 16 Newton. So the magnitude or the resultant force is non-zero. Then the torque Q, yeah, the torque, yeah, if we see the torque, yeah, 45 times R, also 45 times R, this is become non-zero, yeah, but in 30 Newton and 30 Newton, this is become zero, yeah, in the opposite direction on the circle. So here it is become the zero because on the opposite direction in the circle, but for the 45 and 45 here is not zero. So the question, the answer is resultant torque also non-zero. The correct answer is A, both of them non-zero. Number 12. A charged oil drop is held stationary between two charged parallel plates. Top plate and bottom plate charged oil drop. So, which force act on the oil drop? Okay, on the oil drop we have let's say two force here. Let's say this is oil. The oil have weight as mg, and the oil also with electric field, from the electric field force on electric, the force, this is QE here. So which force act on the oil? Both electric and gravitational, is it correct? Only electric only, gravitational only, neither electric or nor gravitational. The answer, the correct answer is A, both electric and gravitational. Okay, let me continue for number 13. Number 13. In which example it's not possible for the underlying body to be in equilibrium? Yeah, not possible for the underlying body, yeah, in the equilibrium. An aeroplane climbs at a steady rate. Yes, not possible or possible. An aeroplane tour glider at the constant altitude, or a speedboat charge direction the constant speed, or two boats tow a ship into harbor. Okay. Uh this is the question is not possible under to be equilibrium. The aeroplane can be equilibrium if the aeroplane is move in constant speed. Yeah, this is not as the answer. An elaborate told the glider on the constant altitude also because this is in the constant altitude. See, a speedboat changes direction at the constant speed. At the constant speed, this is equilibrium also. Two boats tow a ship into harbor. This is the I think this is the answer, correct answer, because if two boats tow a ship into harbor, they will be on the maximum speed or they will have an acceleration. Okay, the answer, correct answer is D. Continue number 14. A car mass 1100 kilogram traveling constant speed in 15 meter second minus 1 up the slope inclined 10 to the horizontal. The combined frictional force acting on the car directed down the slope and R equals to W over 5, where W is weight of the car. Okay. What is useful power, output power of the car's engine? Okay, we have the power is let's say uh, we draw the force here and here. This is sorry, this mg, and here is mg sin, and here is mg cos, and also here is frictional force. So the total force here equals to driving force minus frictional force, then minus mg sin theta equals to 0. Yeah. So the driving force, it's mean frictional force plus mg sin 10. Frictional force, yeah, around W over 5 plus W sin 10. And if we calculate the W is 1 times with 9.81 because the gravitational is 9.81. Yeah. Yes, equals to 1791. Yeah, 791. If we divide it by 5, This is equals to 2158.2, and W, yeah, as we know, W is 1100 times 9.81, yeah, uh, and sine 10, yeah, oh, sorry, times with 1100 times 9.81, this is equals to 1873.8, yeah, and we calculate plus with 2158.2, it's become 3, sorry, this is 5 4032.8 03, yeah, this is driving force in Newton. So the power equals to FV. F is driving force, yeah, 4032.23 times with 15. So we can, this is times with 15 equals to 60, yeah, this is around 60,000 for it watt, also equals to 6 kilowatt. The answer is C. Okay, continue number 15. An old-fashioned 60 watt lamp converts 95% energy supply into heat, yeah. And 4 watt modern lamp has same power output of light as old-fashioned lamp. Yeah, what the efficiency of the modern lamp? Okay, we have old-fashioned is 80 and converts 95. Yeah, so we can for the general formula of efficiency equals to power output, power input, yeah, times with 100%. So the uh, converted into heat, 95 percent. That's the the efficiency around 5%, yeah. This is P out over P in is 60 watt, yeah, time with 100%. So we get the P out equals to 0.05 times 60, yeah, this is around 0, this is about 3 watt. So for watt modern lamp has same power output, yeah, same power 3 watt, yeah. So the efficiency for the modern lamp, yeah, the modern lamp equals to PO over PE. So this is 3 over 4 times with 100%, this is equal to 75%. Yes, the answer, correct answer is C. Number 16. A bit is released from rest at the point P and slid along wire as shown. Yes, the track loops around from vertically circle diameter 40 centimeter and the track loop around from vertical circle diameter 40 centimeter at the point Q. Yes, here diameter for the bed has a speed 1.4 meter second until here. So the track sorry, air resistance and friction on the wire is negligible. Yeah. What is the height of each from the which bed released? So we only use the formula of energy conserve. Yeah. Then potential energy here plus kinetic energy here equals to potential energy here plus kinetic energy here. Yeah. So let's say the potential energy at point P plus kinetic energy at point P equals to potential energy at point Q and kinetic energy at point Q. We have mgh on P and we have a half mvp square. So we have also, and the point Q is mgh on the Q plus a half mvq square. Yes, this is about the energy conserve. Yeah. So because at the point P is rest, so we decide this is equal to 0. Yeah, we can cancel it. So also if we see this equation, we have some of the variable we cancel here, but m we can here m and then m. So g yeah, g, let's say g10. Yeah, hp is h that we want to find it. Let's say g also 10. hq is 40 centimeter, in meter is 0.4 plus a half m is already cancel it. vq is 1.4 square. So we calculate this from 1.4 square, yes, equal to, and then divide it by 2. Yes, this is 0.98 plus this is 4 plus 4 equals. So after that we get a 4.98, yeah, divided by 10. So divided by 10, this is equals to 0.498. Yeah, we decide this 0. Let's say this is about C. Yeah, about C. Yes, that's